we've been thinking about the DART mission, which is this awesome mission where they're going to fire a small spacecraft at high speed into an asteroid to try and redirect it. And we've been trying to think about the sort of the ratios of the masses and things involved, and how on earth this works from a mechanical point of view. So we've got together some really high-tech equipment to try and do this demo of what's going on. The spacecraft hits an asteroid, and this is a particularly good choice of asteroid because it's actually in a binary system. So the asteroid that's going to get hit is going around another slightly larger asteroid. Now the mass ratios between those is roughly the same as this bag of rice and this N-gauge GWR pannier tank. And how big is the spacecraft that's going to do the impacting? Well, it's about the mass of one of these grains of sand in this little vial here. So it is pretty tiny compared to the asteroids involved. So how on earth can it work? How can it actually successfully slow down the asteroid? Well, one thing we need to think about is the dynamics of the system. So here's the parent, and here's the companion asteroid. And the companion asteroid is merrily trundling its way around its parent. This whole system is barreling around the sun at really high velocity. If you wanted to slow down the system, you would need to have a bigger impact or a lot more velocity. But by trying to slow down just the companion, things get a bit easier. The companion isn't actually going that quickly around the parent, which is obviously a great choice and why DART is aiming for this thing. If we were to use our scale here, we need to take one of these grains of rice, fire it out of a gun to hit this thing, to get about the right scales of speed. Funnily enough, we don't have a gun available, so instead we can think about how we transfer the right amount of momentum. Now momentum is mass times velocity, so if you have a larger mass, you have a slower velocity but the same impact. So conveniently, we could use one of these. So obviously the grain of rice has got a little bit more mass, so we don't have to fire it as quickly, and in fact, it's roughly, and I do say roughly, you can scale it down how quickly I can throw this stuff. So I'm now going to try and slow down the asteroid with my impactor. I missed, and I think I missed again actually. So I'm going to throw a load. Let's have lots of impactors. Yeah, so I'm not actually hitting it very well, which is a whole different problem, and the challenge of hitting an asteroid has just been demonstrated. We didn't knock the train over. We didn't slow the orbit down dramatically. DART is not going to do that. It is a fractional change to the orbital period. It's going to slow it down a minuscule amount, but we will be able to measure that. And if all goes well and it manages to hit it, we will successfully, or NASA will successfully for the first time, manage to play, ping pong with objects in the solar system.